Hey, logic class, what's up? Jared Kingard, your professor. I'm going to pick up where we left off in the last video, which was a discussion of conditional proofs and indirect proofs. What we're going to look at today is a little bit more of a complex version of conditional proof. I'm going to show you how to do a conditional proof inside another conditional proof. All right, and this can be very handy when you have a lot of premises that involve conditionals. Notice that both my premises and my conclusion in this case are all conditional statements. All right, so the first thing that I'm going to do is I'm going to assume the antecedent to my conclusion, because ultimately what I'm trying to derive is if L, then not M or O. So one of the greatest strategies we can use, or best strategies we can use, is to assume the L. And of course, this is V via ACP. Now once I've done this, we can clearly see that with line 1, I can perform a modus ponens. So for my L on line 3, I'm going to perform a modus ponens on line 1 to derive if M, then N or O. So if M, N or O, and this is via 1, 3 modus ponens. All right? Now at this juncture, we see we have another conditional. And one of the easiest ways to derive this is going to be to pull the same exact maneuver. We're going to assume M on line 5 via ACP. And ultimately, we're going to try to derive another conditional. So now that I have an M on 5, we notice at line 2 that my antecedent to this conditional is an M. So I can take this M, apply it to line 2, and derive a not N. So that's exactly what we'll do. Not N via 2, 5 modus ponens. All right. Now that I have a not N at line 6, I can, and an M at line 5, I can use modus ponens on line 4. So on line 4, I can derive N or O from 4, 5 modus ponens. Now the reason I did this is because I realized that I got a not N from my first use of modus ponens here. And I know that if I have a not N and I have a premise that says N or O, that I can derive an O. Because if it says I have an N or an O, but I don't have an N, then I must have an O. So at line 8, via the rule of disjunctive syllogism, we can derive an O. 6, 7, ds. Now at this point, I can cash out my conditional proof. We move line 9 over, and because I assumed M at line 5 and derived O at line 8, we know that if I have an M, then I have an O. And that's from 5 through 8. Conditional proof. Now then, we can use one of our handy-dandy rules of replacement here called implication. We can use implication to convert a conditional statement into a disjunctive statement. All right, so through implication, I can get not M or O from line 9. Now notice, the consequent of my conclusion is not M or O. And the assumption I made on line 3, L, is the antecedent to the conclusion I'm trying to derive. So through the rule of conditional proof, I can now close out this conditional proof, kick back my line over here, line 11, and get L implies not M or O from 3 through 10, conditional proof. So when you see that you have a conditional as your conclusion, one of the best strategies to use is to use conditional proof. Further, when you notice that you have multiple conditionals as your premises, you might think to try and use a conditional proof inside a conditional proof to help you ultimately get the conclusion that you're after. All right, I hope that this helped everybody.